Good to go? Hello. Hi, mi chiamo Matteo. I'm not from here. That's all the Italian that will be in this talk, so buckle up. So I'm here visiting from Berlin, and I'm here to talk about professional level game UI. And I'm presenting for the first time a tool that is tailor-made for making UI in games really, really easy. So game UI is a little bit special. If you compare it to something like what you see on a website, no one really cares if your buttons take 300 milliseconds to load. If you click something and you have a spinner, not a big deal. Turns out in games, that's a really big deal because you've got about 2 milliseconds to do all the work that you would have expected to do on the entire web page. So that's what this tool is about. It's about making things really easy to build and making those things run really, really fast. So the idea is somewhat new. The way this works is there's a specialized compiler that understands the entire flow of user interface code in games, and using that, it spits out really hyper-optimized code specifically for your game, and it does it in a way that's really interesting in that you can hot reload it, which means your game can be running, and you can make changes in your UI code, and without stopping your game, all of your changes become visible. So let's jump in and hope that YouTube works. Allora. And if not, this will be a really short presentation. One minute. Magic. Okay, here we go. So what I'm going to do here is I have Unity here on the left, and I have UI code here on the right. And what you'll notice is all of this is hot reloading. So I'm just typing, and things start changing. So first off, I put in a nice little background image, and I have a style file down here to demonstrate how that works. And I'm just going to throw up a bunch of Evolve logos, because they look kind of cool and neon, and yeah, here we go. So I just start adding changes to this, and then maybe I want, instead of just one logo, I want to put in a list of these so that I can just take a bunch of colors, for example, define that all in local state, and then immediately have all these changes reflected and be available in my game. So you can define colors in a bunch of ways. But I think what I want to do here is randomize this. So I've just added a button, and any code that I have in my C# types, I can immediately run in UI. So here this shuffle method comes completely out of C#. I did no interop, no binding, nothing like that, and it's immediately usable. And now when I click this little randomize button, my logic just changes. So the last thing I want to do in this little demo is put an animation on here, because I like Las Vegas and neon blinking signs. So what we do for that is, in our style down here, just define a transition. And what this means is that anytime the backing data for the color changes, immediately an animation occurs instead of just flipping from one value to the next. So animating things is really easy. Bringing in your own data is really easy. And this is all possible because this compiler intrinsically just understands everything about your UI code. So the other part of this is a big demo that I did that I definitely don't have time to show, but if you'd like to see like a real world use case, come and talk to me. But let's dive in and look at what the actual UI code looks like in a little more detail. So at a high level, everything is baked directly into this UI language. So in the top here, I have a C# class that I'm going to get data out of. In this case, all it really is this current quest that has a list of objectives. And the rest is basically one-to-one. So we have a title, and there's our objective log. We have a sort function that we're running, which puts all the completed quests at the bottom and all the still pending ones up top. And that was just regular C# interop. That's nothing special with the language. That just says run C# code now, and it immediately updates and just works. And then the last little bit of this is that we can iterate over a list of our objectives. We can apply a style so that they're horizontally aligned. And then we have a checkbox that has a data binding property called isChecked, which we just read out of our C# type. And with the text, we just also read that right out of C#. And all of this can happen with no changes to the code whatsoever. On the C# side, you're not recompiling, it just works. So now I'll show a little bit more of an involved demo on what you can do with a styling system here for UI. So this doesn't look right. Here we go. So we just have 6 logos, and they're done in the same way before. So we just have a loop looping 6 times, and we get logo components, and they have a style called color. So now we're going to show the flexibility of a styling system for a UI like this. So I'm going to define some colors that I like, and we'll make the first one this nice bright yellow. And instead of just applying it to one, I'm going to use a query here to say grab every even child and make it yellow. And then there's other stuff, like you can make the first one green, or we could add another color and make all the odd elements red. And all of this is just kind of working like magic. So you have all of this power and flexibility with a styling system, and all of its hot reloading. So other cool things we can do, I think this one just makes the 5th one white, and then there's a last child selector. But then the next cool thing is you can actually style things based on conditions. So you can write a custom condition. Oh, that did not do what I wanted. Come on, where were we? Yeah, here we go. So you can write actual style queries. So you could say, if the player's health is low, start running an animation, or style the buttons differently, or make the health bar a different color, that kind of stuff. You can do that all on your own. So there's no special logic needed. That's just exposed directly through a style system. And then the last thing we want to do is we have this nice animation from before. So I'm going to use a composable style to mix these in together. And once we have that running, what should happen is we get this nice color transition in an animated way, and they animate over because I gave them a little bit of margin. So that's fun, but it would be even cooler if each of these elements could have its own little piece of animation data. So what we'll do now is add a variable on our elements for a margin offset, and now instead of all animating to the same place, they all have their own animation target. And this was all done in about 10 lines of code. So you can kind of extrapolate across an entire game and see just what happens when you have this much power. So styles are a way to make UI elements really reusable. They're great for designers who just intrinsically understand how styles get applied to elements. There's a ton of things that you can add to this. You can create variables, styles, you can have this powerful query language. There's a lot of power here. So like we also kind of looked at, you can animate literally anything. So of the 150 style properties, you can always apply like a spring physics system. You have all of the normal easings and easing curves. You can do keyframes, Beziers, whatever you kind of want. And if whatever I ship wasn't what you wanted, then you can just define your own. And layout is a super complicated topic, typically in UI. So we ship with 10 different layout types, and there's a bunch of ways to do sizing. So you could size things based on your biggest child, based on your smallest child. You could just have it stretch. And this is a really easy way to compose elements together and make something that looks really cool and complex really quick. And so drawing in games is also a really critical topic. So what we can do here is everything in Evolve is based on signed distance field rendering, which means that with no work from your side, everything comes out really anti-aliased and crystal clear. Because this compiler also already knows about your entire game, it automatically atlases your textures and can optimize your draw calls for you, and you don't have to think about it. In fact, if you do nothing, the default is the entire UI gets one draw call, which is pretty cool. And the last thing I want to talk about is this thing is built to handle thousands and thousands and thousands of elements every single frame. So most UI systems out there are built in such a way that they optimize for the case where nothing changes. So you, sort of like the web, you click a button and then you expect things to change kind of naturally. But that's not at all how games are built. Games are dynamic, games change constantly, and so this whole system is built to handle that. And it's fully threaded, it's built with burst, there's no allocations, and as you can sort of see from the profiling snapshot there, I have about 2,000 elements. For reference, that would be about the size of an Amazon page with all of the items and articles on it, and that's running, updating, and rendering in 1/5 of a millisecond. So that was my very quick presentation, thank you. And I'm looking for studios to partner with, so if you are struggling with UI, I would love to talk to you. And also, I am hiring. If you like this stuff, if you like graphics, if you like UI or rendering or high-performance code, I would love to talk to you. Thank you.